Remember we said that it's rare to find one kind of atom all on its own? True, it sometimes happens, and when it does, we call that stuff an element, like the carbon in your pencil. But most atoms stick to other types of atoms somehow. They usually like sticking to their own kind too. This video shows how they can do that. We'll start with the oldest and simplest kind of atom, hydrogen, made of one positively charged proton and one negatively charged electron. The electron moves amazingly fast around the nucleus. Why then doesn't it whiz off into space? Well, what kind of force would the electron and proton feel towards each other? Attraction or repulsion? I hope you said attraction because they are oppositely charged. It's this force that bends them into moving in a circle around the proton. It's why atoms don't fall apart. Also, an atom is three-dimensional, which means that the electron really whizzes around in the shape of a sphere, not a flat circle. Atoms are more like marbles than coins. But here, we will simplify the picture and show the electron in a circle and not moving. Now the main question we're asking is, what happens when two hydrogen atoms come together? Let's bring another hydrogen atom onto the stage and see what happens. Will they bounce off each other and stay separate, or stick together? Let's take a closer look at the electrons and protons. What happens when the electron from hydrogen atom 1 gets near the proton of hydrogen atom 2? Electron 1 and proton 2 don't care if they belong to different atoms. They will still be attracted. And here's the thing. The shell of atom 2 is not full. It can take up to 2 electrons. It has the space to allow the electron from atom 1 to visit it. The same deal happens between the electron from atom 2 and the proton from atom 1. This means that both electrons wrap themselves around both atoms, and they act as a kind of glue to hold them together. The two atoms become one molecule. Because the shells are partially empty, they can overlap and merge, and the shared electrons then spend more of their time between the two nuclei. Because the nuclei are both attracted to both electrons between them, the atoms stick together as a stable molecule. This joining caused by atoms sharing their electrons is called a covalent bond. Is there a shorthand way of writing a hydrogen molecule? Scientists sometimes write a covalent bond as a stick between the two atoms to show that they are joined. This way of writing is called a structural formula. They could show it even more simply as HH to show that the two hydrogen atoms move around in pairs. Even simpler, they could write it as H2, with the 2 standing for the number of hydrogen atoms joined by the bond. The 2 is written as a subscript, that is, a little 2, a bit below the hydrogen symbol. This way of writing a hydrogen molecule is called a molecular formula, or just formula. Now let's see if helium can bond with itself, like hydrogen can. Helium, atomic number 2, is made of 2 protons and 2 electrons. When we bring 2 helium atoms together, we find a big difference compared to hydrogen atoms. Can you tell what it is? The electrons from helium atom 1 can't get into the shell of helium atom 2. Why not? Because helium's electron shells are already full. That means that helium atoms can't share their electrons. Helium atom 2's electrons can't get into helium atom 1's shell either. And this has the effect that a bond cannot form between them. In fact, because their electron shells are full, they can't share electrons with any other types of atoms at all. Helium atoms are always on their own. We say that they're monatomic, meaning that they are always found as just one atom. This is also why helium is always written as just He. We could put a 1 in the formula, but scientists agree that we can leave the number out when there is just one atom, and it's not needed. Maybe we should feel sorry for helium, or maybe we should admire it because it doesn't need any other atoms. That's why it's called a noble gas. In our next video, we will look at how oxygen, nitrogen and carbon bond with other atoms.